All right, so before we talk about a new topic, I would like to just review very quickly the nested loop that we talked about on Monday. Guys, can we start? Okay, let's start. I want to finish the topics about loops very quickly, and then we got to go into the topics for classes and objects. Okay, this is the nested loop that we talk about. Let me remind you very quickly the problem we're trying to solve. Okay, basically you're given an array of integers, for example 1, 2, 3, 4, or 1, 4, 2, 4. What you really want to find out is either true or false if there are any duplicates in the array, meaning that if you, for example, you can see for this array over here, at index 1 and index 3 over here, the elements there are the same, so we do have duplicates. So now, how can we solve this problem? The intuition is we have to compare every pair of combination of the indices in the array, so that if the pair of indices store the same elements, then we have duplicates. Okay? And then it turns out the solution is very related to the videos that we are studying for this week. You want to say as soon as we find out there's any duplicates, we're going to exit from the loop. Okay? That's something I want to show you quickly. So I want to help you a little bit over here about studying the slides. Okay? Let's have a look at the first, in the slides, I got 3 working versions for you, but I will just review 2 of them. Okay? So the first one and the last one. The first one, just to give you warm up quickly. Okay, let's say currently the first example we have array A over here, and array actually got 3 elements inside. You can see there's no duplicates. So what we expect to see is we expect to see false eventually. Okay? And then we simply declare a Boolean variable over here called has duplicates. You can think about this problem is very similar to if you want to find out if there's at least one positive number in the array. The problem is very similar. Okay? So initially this Boolean variable is simply false. As soon as eventually we want to get to the point that as soon as this Boolean variable is set to true, we're going to exit from the loop. That's basically what we want to do. Okay? So now let me show you the very first version. Basically for the very first version, I'm going to show you 2 possible test cases. For test case number 1, we got 1, 2, and 3. Okay? And for test case number 2, we got 4, 2, and 4, the same block of code. But in this particular case, we do have duplicates. So in this case, we do expect true to be output to the console. Okay, so we're going to consider these 2 test cases for version number 1. So now let me give you a little bit of hints on how to study this particular loop. You really want to sit down by yourself and then think about it a little bit more carefully. I'll tell you what the details you have to pay attention to. Number 1, if you look at the code structure here, it's very standard. We have 2 loop counters over here, I and j. Each one of them starting from 0 and go all the way until and including a.length minus 1. In this case, a.length minus 1 will just be 2. So that means I can be 0, 1, or 2. J can also be 0, 1, or 2. Okay? Given that it's a nested loop, as we talked about on Monday, you can review the flowchart that we did together. Okay? Review that. What it turns out to be, we're going to basically have all the 9 combinations of the loop counters. You're going to have, for example, 0, 0. You're going to have 0, 1. You're going to have, sorry, you don't see that. Let me just move that here. Okay? Let's see the loop counter over here. Okay? So let me just do it again. So basically, for the value of I, you're going to have 0, 1, and 2. For the value of j, you're also going to have 0, 1, and 2. Okay? For all the iterations, for example, when you talk about the outer iteration over here, you're going to have I being fixed to be 0. In that case, the very first iteration for the inner loop, you're going to consider 0 and 0. Okay? And then for the second iteration for the inner loop, you're going to consider 0 and 1. Okay, let me just highlight it a bit more carefully. So 0 and 1 is for the second combination. And then for the third iteration for the inner loop, you're going to have 0 and 2. Okay? So these are the 3 combinations we consider first. Okay? And then similarly, for the second iteration for the outer loop, let me use orange over here. We're going to fix the value of I to be 1. And for the very first iteration for the inner loop, we start over again. It's going to be 1, 0, and then 1, 1, and then 1, 2, okay, and etc. That's how we end up having 9 iterations in total. Again, this is why you can see this 0, 0, 0 here. This is the first iteration of the outer loop. That's the second iteration, and this is the third iteration. Okay? So that's basically we just consider every one of them. For this particular array, which let me just give you one example. How do you read the table? Let's say for this particular example, let's say for this particular one, when I is equal to 0 and j is equal to 1, what does that mean? That means we are considering this pair of elements over here as index 0 and index 1. They are basically 1 and 2. That's why you see 1 and 2 over here. They are not the same, which means for this particular instance, we haven't found any duplicates just yet. Okay, so they are not the same. So that means we haven't found any duplicates. So it remains to be false. Okay, and we just go on like this for every other iteration. For this particular case, it doesn't really matter all the other iteration because you simply just have no duplicates. So eventually you can see all the value for has duplicates always remain to be false. Okay? But in the next example, we're going to see at some point it's going to be reassigned to true at some point. Okay? So now let me just say one more thing here. You should really notice that, as we mentioned briefly last time, when you try to check the body of the loop over here, we have to say I is not equal to j over here. It's really important. We want to make sure every time when you compare one pair of elements, you always compare 2 distinct positions. For example, you don't really compare A0 against A0. You don't really do that because they will just be true. They will just be the same trivially. So that's why somehow we want to discard this particular comparison. That's why when I move on to the next version there, you're going to see this can be effectively eliminated. Okay, we'll see. And one more thing to say. You can see for this particular row, we are comparing 0, 2. 0, 2 basically are referring to 0 and 2. So these 2 elements over here. If you look at another line over here, which is 2, 0. If you look at that, it's basically comparing the same 2 elements over here. For example, 2 and 0. You're really comparing the same, but why are you doing that twice? So there's some redundancy over here we would like to get rid of. So eventually, when you get to the final version in the slides, that's maybe the code you will like to write. It's more efficient and also correct. Okay? So now let me show you the second test case. In this case over here, you can see that this you can see the very first 2 iterations, the has duplicate just remain to be false. Because when we compare 0, 0, in which case we are comparing the same elements, this simply doesn't count. That is why this particular operand is going to be false. And when we get to the second iteration over here, when we compare 0 and 1, we are basically comparing 0 and 1, which is 4 and 2. 4 and 2 are different, so we haven't found any duplicate yet. That is why it still remains to be false. So when do we actually find the duplicates? Let's see this. Exactly over here. If you look at 0 and 2, so that means we are comparing this element over here and this element over here, which is 4 against 4, and 4 is equal to 4. That is why you get exactly the true over here. Okay? So that means we have found the duplicates this early. However, the current setup, because the state condition simply tells us I must run from 0 until a.length minus 1. Similarly, j must run this many values as well. So that means even though we found true already, we still have to go on for the rest of the 6 combinations. So that is not so efficient. It is not wrong, but it's just not efficient. I would like to draw some connection here. What we are doing over here, if you compare with your tutorial video this week, so this is more like a version number 1 that you're learning. We would like to move on from version number 1 to version number 4, which means we just want to modify slightly the state condition there to say as soon as a duplicate has been found, we can exit from the loop. Okay? And then we also want to get rid of this accumulation over here. That's also possible. Okay? So these are the 2 things we would like to improve to move on to the next version. I'll show you the code for the next version very quickly and give you the insight. Okay? So far we have seen 2 test cases for version number 1. It works. You can feel free to use this version here if that's more intuitive to you. But I'm just going to show you a better version that also works. So now we move on to a different version. You can see the one that's highlighted in yellow are exactly what's being changed. Let's go over them very quickly. Okay? So we still have this particular has duplicates, Boolean variable initially is still false. Okay? Nothing changed. However, you can see that we are adding a conjunction to the state conditions for both the outer loop and the inner loop. In this case, we simply say we're going to stay in the loop as long as we have not found the duplicates. Okay? So this simply means have not found duplicates. As long as we have not found duplicates, we're going to stay in the loop. As soon as we find out the first duplicates, exit from the loop. Okay, I'm going to show you exactly how that works. Again, the first test case I show you, there's no duplicates. It's going to be 1, 2, 3, and 4, no duplicates. However, it's already an improvement already. If you look at the table over here, you can see the way we enumerate all the possible iterations is already fewer. We used to get 0, 0, 0, 1, and 0, 2. That's what we used to get. But what about now? Now, actually, we got 0, 1, 0, 2, and 0, 3. What's missing here? What's missing over here is 0, 0. We are not considering that anymore. It's simply just eliminated from the possibility. How does this happen? Okay, I'll get to that. Another thing to notice, you can see that over here, we already consider 0, 1, right? That's already considered. And notice that when i's value is incremented to 1 over here, you can see over here, 1, 0 is also not considered anymore because they're redundant. If you already consider at position 0 and position 1, you don't have to compare them again. So that's kind of the efficiency I talk about. Okay? So how does this happen? This is the trick. Okay? You can see that over here, the trick is really about how we set up the initial value for the loop counter j. In the very first version, we simply say j always start with 0. But now we say that it don't start with 0. Rather, it start with the value of the current value of I plus 1. For example, you can see that over here. What does it guarantee? It guarantees two things. Number one, when you say j is simply I plus 1, j cannot be equal to I. So that means we don't consider equal positions anymore. Okay, that's number one. And number two, when you say j is simply I plus 1, it turns out we can also eliminate redundant checking. Okay, let me show you the pattern. It's quite easy to observe. If you look at that, basically for the very first iteration for the outer loop, you simply get 0, 1, 0, 2, and 0, 3, right? You can see all the way to the maximum index. Okay? So now, how does the loop counter change their pattern in the second iteration? For the second iteration for the loop, the I value is just going to be 1 to begin with. But now, what about the very first value for j to consider? J is simply just going to be I plus 1 rather than 0, which means it's simply just going to be 1, 2, right? 2 is 1 plus 1. And then go all the way until the length minus 1, which would be 1, 2, and 1, 3, right? That's why you see only 2 rows over here. You can see the number of combinations we have to consider for each iteration was just decreasing, right? You can see over here, we only got 3 combinations. And for over here, we got 2 combinations. And for over here, we got 1 combinations. In total, we got much less than 9 combinations to go. Okay? It's a very quick pointer to what you should really pay attention to. Okay? Yes? The second version, we'll get there. We'll get there. We're going to see another case. In this first test case over here, you can see 1, 2, 3, 4 in the array. There's no duplicates. So that means we still have to check many iterations before we can exit. Okay? But now, the same block of code, but let's change to another array. Okay? That's going to be the last case to talk about. Let's say now we got 1, 2, and 3, 2. In this case, you can see we got duplicates over here at position 1 and position 3. Let's see exactly how the early exit can be in effects. Okay, let's try that. And the way it works is very similar to how it works for the version 4 of your tutorial video. It's just now we talk about nested loop. Okay, the same block of code. I want to draw your attention first of all. When we run the very first iteration for the outer loop, when I is simply equal to 0, in which case j will be 1, 2, and 3. So what are we considering? We are basically considering 0, 1, which there's no duplicates, and also 0, 2, 1 and 3, also there's no duplicates, and also 0, 3, 1 and 2, which also no duplicates. That's why you see false, false, false so far. Okay? So now, let's move on to the second iteration for the outer loop. For the second iteration of the outer loop, I will be incremented to, you can see I will be incremented to 1. So that's why we just got 1 over here. Okay? And the initial value for j is simply just going to be I plus 1. Okay? So now, how is that going to compare? We're going to start with 1, 2 over here. 1, 2 is referring to these two indices, 1 and 2. So we got 2 and 3. So 2 and 3, no duplicates. So that's why you still see false. Let's go to the next one. When we increment the value for j for the first time, it's going to be considering 1 and 3. When you consider 1 and 3 over here, you can see 2 and 2. They are the same. So that's why you really want to see this is exactly we set the duplicate Boolean variable to be true. Okay, so what does this mean? This means we found duplicates. Because we have at least one violation, we have at least one witness that tells us this is a duplicate, we can now exit from the loop. But how does it work? As soon as we set this particular Boolean variable has duplicate to be true, okay? And then we simply go back to the header of the inner loop. And then you can see has duplicate has been set to true. We got exclamation mark, as I explained in the video. Not true is just going to give you false. So false is going to make this particular state condition false. So you exit from this inner for loop. Okay, that's how you exit from there. And then what's more? If you, let me use another color. So now once you reach the end of the outer loop, you will go back to the header for the outer loop over here, right? And the has duplicate Boolean variable remains to be true. So when you check this particular state condition part again, has duplicate remains to be true, not true give you false. And then false is going to make this state condition here false. So you exit from the outer loop. Okay? You can see once you set the has duplicate to be true, it's going to make sure you exit right away. Okay? That's something you want to get used to of writing the nested loop. Okay, it's a very quick walkthrough, but I think you definitely should spend more time thinking about this in isolation by yourself, and then let me know if you got trouble. Okay? Any questions about this example? Okay, again, we are showing you maybe actually different versions of writing this nested loop. In the lab test or in the exam, if I do require you to write some code like that involves nested loop, you can choose either version as long as it works. However, if I give you some multiple choice, you should really know how each version actually works exactly. So I might just change the operator a little bit to actually ask you what's going to be the consequence. Okay, so we're still doing well with the time. I want to spend just maybe another 10 minutes very quickly. So there are some common errors for the nested loop. For the loops, I want to talk very quickly about, and we finish the topics for the loops. Okay, and hopefully that will also help you on the future quizzes or the lab test. Let's go over them very quickly. Okay, so now we do have quite a number of, each one of them will take only a little bit of time. So let me go to the common error number 1. Okay, let's have a look at this fragment of code over here. If that's, hopefully that's not too small, okay? Let's have a look. The same over here. Okay, so basically it's very similar to what you're required to do for the lab exercises. We want to say basically as long as the user enters Y for yes, we're going to keep letting them continue with whatever they want to do. Maybe they want to keep entering numbers. Maybe they want to keep entering some string names. Okay, that's what we want to do here. So now with this fragment of code over here, it will compile, but there is a logical error over here, which is quite easy to make, but hard to find. Okay, let me tell you exactly what it is. If you look at the first line over here, we say that we declare Boolean variable user wants to continue, and then we intend to simply use that Boolean variable to say as long as user wants to continue, we keep going. keep doing something. However, there's something you may not have noticed. Usually, we have to say user wants to continue is explicitly initialized to be true, so that when we try to check this state condition for the very first time, it will just be true. So at least we let the user to enter something, at least for once. But now, let's say we didn't do anything like that. Just that. In Java, there is something called default value. I'll write it down. Default value. Default value in the sense that for any variable, if you do not explicitly initialize a variable, there will be some value stored over there automatically for you. So you have to be very aware of this issue over here, okay? In the case where the Boolean variable is simply declared without being initialized, the default value is not true. It's actually false. Okay? By default, it's simply just going to be false. By default. So it is as if you actually said this is actually it's assigned to false. What's going to happen here? If it is simply just false, that means when you try to check this state condition for the very first time, user wants to continue, which will be, by default, false. So you don't even enter the loop for the very first time. So that's a logical error. You really want the opposite. Okay? So that is something very common to make a mistake about. Okay? Be careful. That's about the first one. Let's see the second one. The second one is actually quite easy. Okay? If you look at this code over here, what's wrong with that? If you look at the initial value over there, and the state condition, and also the updates for the loop, anything you can spot? Okay? Always be careful about the state condition over here, especially you're using I over here as the index expression over here. Let's say a.length, let's say a is simply pointing to an array of size 3, 0, 1, and 2. And over here, you're saying that it's less than or equal to, so equal is actually included. A.length, in this case, is simply just 3. So that means you do allow 3 to be included, right? So that means when you try to run the iteration over here, it's going to be 0, 1, 2, and 3. So when I gets to 3, 3 less than or equal to 3 will still be true, which means you will still use it. So now, if you use A3 over here, we know what's going to happen, right? 3 is not valid, you get array index out of bounds exception. Okay? So that's what you'll get. Array index out of bounds exception. Okay? Be careful. Okay? Let's look at the next one. So now, this one is a little trickier. Okay? I'll just let you read the code very quickly, and then I'll discuss it. The question is, can this while loop, which initializes I to be 0, and then we do increment I, but in a slightly different position. We want to know if the following code is going to print out all the elements in the array. Typically, we put I++ at the end of the while loop. But now we're not doing that. We're doing the opposite. We put it in the very beginning. Okay? That's something you would like to see if that will actually work. Okay? So now let's use this example here. The answer is it's not going to work. Okay? Let's see exactly why. Okay? Again, you want to just draw a very small table for yourself very quickly. Okay? We know that what's going to happen is the value for I and also the expression we would like to print out, which is AI. Okay? So initial value for I is simply just 0. Oh, by the way, a.length in this case is simply just 4. So we keep track of that. Oh, thank you. Thanks. So now over here we have an array over here of size 4, 0, 1, 2, and 3. And then initial value for I is simply just 0. And then we want to keep track of AI, which is going to be printed out. A.length is simply just 4 in this case. Okay? So now let's trace it very quickly. The first time we check the state condition here, 0 less than 4 is going to be true. Okay? However, you can see the 0 is not used right away because we try to do I++ first. So that means without using this, we're going for 1 for the first time. Okay? And then we're going to print out a 1 in this case. Okay, A1 is going to print out 23. Okay, what about, and then we simply just go back to the header of the loop, and then we check to see 1 less than 4 is going to be true. So that we're going to go to the body of the loop, and now what's going to happen? We're going to do I++ again. You can see we're kind of doing the increments too early, right? So now we're going to get 2 over here. After increments, we get 2, and then we're going to print out A2, and that is going to print out -4. Okay, and then it keeps going. Are we going to run into array index out of bound exception? Okay, the answer is yes, you would. Let's see exactly why. Okay, back to the original question: is this fragment of code going to print out all the elements in the array? Of course not. First of all, okay. And then the second question is: are we going to run into array index out of bound exception? The answer is yes. Okay, let's try very quickly. So now, after the second iteration, we're going to go back to. So now the current value for I is 2, right? So we don't increment I at the end anymore, only in the beginning. So now I is actually 2, and then 2 less than 4 is going to be true, right? So we're going to go into the loop. And then we're going to increment the I right now in the beginning. So it's going to be incremented from 2 to 3, and then we're going to print out A3. Okay, which means we're going to print out A3, which is going to be 5. Okay, you know what? I just wrote it wrong. Okay, let me just change that very quickly. So now A1 is actually -4, not 23. And also A2 is actually 79. Okay, so now at the end of the third iteration, we don't do increments because increment is supposed to be done in the beginning. So now let's try one more iteration and we'll see. The current value is simply just 3. So now when we go back to the header of the loop over here, so we got 3 less than 4, which will still be true. That means we go into the body of the loop for the 4th time. So now, before we try to use 3, we actually increment the value for I. So which means you'll be incrementing it from 3 to 4. And then we'll try to do this particular printout, which will be A4. Is there A4? No. It's array index out of bound exception. Okay, so if I give you this question here in the quiz or in the exam, hopefully you will know how to make sure you know how to trace it, right? Any question about this over here? This one's slightly trickier. Okay, there are many subtleties over here you want to pay attention to. Okay, especially how exactly we run into the array index out of bound exception. Okay, so now let's go on with this. Okay, and I do have 2 possible fixes for you. You can read them through. Okay, they're quite easy to follow. I'll let you study them. Okay, the next one over here, similar idea, but now this is also something I saw some of you guys actually wrote. Okay, let's see the code over here. Okay, it's going to be a similar problem. We basically want to prompt the user to see whether they want to actually continue or not doing something. Okay, first of all, the first line, we simply declare our answer from the user, input the next line, as usual, and then we say the number 2, we declare some Boolean variable user wants to continue. The initial value over here, we simply set it to be whatever the answer user enters. Let's say they enter Y the first time. That means they want to continue, right? Let's say if it is simply just equal to true. So that means we're going to go into the loop and then try to execute the body of the loop. So now, is there any problem over here for this fragment of code? Okay? It's a logical error. Again, it compiles, but you run into trouble at the runtime. I'll give you a little bit hints. What if the user, they actually want to exit? If the user wants to exit, okay, because if the user wants to exit, let's say at this point, input the next line, the user simply say n, a string. And then we're simply going to store n into the answer. Okay? That's it. And now when we go back to the while loop over here, is it going to change the value for user wants to continue? Not really, right? Because user wants to continue is only initialized for the very first time. And that's it. you never update its value according to the user's answer. That's the problem. How can we fix it? Well, very easy to fix. Basically, very similar to the idea about I++. You can think about, abstractly speaking, user wants to continue is your loop counter. You want to make sure at the end of the loop, you want to update it. So how do I update? I only have to insert a line over here. I can say, since I got the answer from the user, the new answer from the user already, so I can say, user wants to continue. I don't need to redeclare that because it's already declared, is reassigned to if the answer dot equals y. So this line over here is very critical. If you don't have that line there, it's as if you didn't have I++ for your for loop. So you run it indefinitely, infinite number of times. Okay? This one here is also very common. So the lesson to learn from here is always you want to make sure you update the loop counter. So eventually the state condition becomes false, eventually at some point. Okay, so now here. So now that's number 4. And that's how you fix it, is I just wrote down on the iPad. Okay, we got 3 more to go. So now number 5 over here, this one here, it's just one example to say, if you try to reuse the loop counter for more than one loop, you want to be careful how you update how you actually start with the loop counter. Let's talk about this example very quickly. Okay? If we talk about this particular example over here, again, let's have an array as an example. Let's say we have an array A over here. Let's say A is simply contains 3 indices. A.length is simply 3. Okay? If you look at that over here, we initialize I to be, let's think about the I value over here. Okay? Let's trace that. I initially is simply just going to be A.length, which is 3 minus 1, which will be 2, right? Okay? A.length will be 3. So I will be 2 in the beginning. Okay? And then we say as long as I is greater than or equal to 0, we're going to keep going. And then at the end of the loop, we're simply just going to do I minus minus. We want to print it backwards, right? I is going to be 2, 1, 0. Okay, you can see even for 0 over here, 0 larger than or equal to 0 will still be true, right? So that means we can go there for the last iteration. And then at the end of that, we're going to say I minus minus. So that means when we exit from the loop, it's going to be minus 1 for the value of I. Okay? Basically, what should be the value for the loop counter when you exit from the loop? It should be exactly loop counter value that will make the state condition false. Because as soon as the state condition becomes false, you exit from the loop. Okay? That'll be minus 1. So now, you can see that we are trying to use I over here for the second while loop. Okay? Let me just make a note over here. So now, when exiting the first loop, I is simply just equal to minus 1. Sorry, simply minus 1. And now, let's see this. Let's say for the second loop, we try to print forwards. So we have the normal I less than A.length state condition over here. So now, basically, we're trying to do minus 1 less than the size of the array, which will be true. That means we do go inside the loop over here. Now, what's going to happen? If you try to print out AI, so now we're going to say A minus 1. There'll be no possibility for this to be valid, right? So now this is just going to be array index out of bounds exception. Okay, again. Okay, you can see it's very easy for your code to compile, but you just write into array index out of bound exception. Okay, that's just another possibility. Okay, you want to pay attention to exactly the loop counter you're using for array indexing. You want to be very careful, line by line. Okay? So the examples I'm giving to you, they're simply just examples. You want to learn about the general principle. You want to be very faithful to tracing the program. Okay? That's the lesson. Okay, sorry. So I think we got 2 more. Okay, how do you fix it? For example, you can simply reinitialize the loop counter outside the first loop. That's what you can do. Okay? But what if I didn't give that to you? You want to know that be able to figure out that's actually wrong. Okay, this particular slide is about wrong syntax, which I do see some students writing that. What's wrong with this particular fragment of code? while integer I is assigned to 0, I less than 10, I plus plus. Is that really what you meant? Not really, right? I think you meant to have a for loop, right? Okay, so this one here doesn't work. When you have the, okay, be careful, don't write this in the lab test. Okay, it's not going to compile. Okay, so you really meant to have a for loop. Only the for loop has 3 parts that you can fill in. How about this? Similarly. So this for loop here has only 1 part. Again, right, it's wrong, right? Just in a symmetric way. This is not really what you meant. Maybe what you meant to say was while. However, as we discussed previously, for the for loop, if you don't want to put any initialization for the loop counter, you don't want to put any update to the loop counter, you can write something like this. You can say, you still need a semicolon for the syntax. I'm simply saying that the first part here is simply empty, followed by the state condition, and followed by another semicolon, and the third part is also empty. It's okay to be empty for the parts, but you just got to put a semicolon. Okay? So these are also common, I would think. Finally, final error. This is very similar to how you might misreplace semicolon for the if statements. Very similar. Okay? Let me get right to the points. Have a look at, very quickly, this for loop over here. Okay? Now, be very careful to every character over here. If I try to execute this fragment of code as a Java application, how many times of hello am I going to print out? How many times? I can tell you that 10 times is actually wrong. So where's the trick? Let's switch to over here. If you look at that over here, this is the semicolon that was misplaced. Okay? I know it's very subtle over here, but you got to be very careful because sometimes in lab tests, if you mistakenly put the semicolon without noticing it, things will be very weird. That's going to happen. So what's going to happen over here? If you got this semicolon over here, that means the for loop is just going to be exactly over here, which means the body of the for loop is simply empty. The body of the for loop is just empty, which means it should iterate by itself for 10 times without doing anything. And then over here, what actually follows that, this guy over here is not the body of the for loop. So this is not the body of the for loop. Okay? So now the output is just going to be hello, just once. Okay? That's something also you want to pay attention to, right? Okay? So if you mistakenly put the if statements with a semicolon right away, it's going to end the if statement right away without any branching conditions, without any branching actions. If you do the for loop or while loop with a semicolon right away, it's not going to do any visible iteration to you. It's just going to do it by itself. Okay? That's the last common error I would like to talk about. Okay? I got about 10 minutes. This is my plan for the new topic. Basically, okay, that's about the loops. And this will be exactly what you have to get prepared for lab test 2, okay, for next week. Okay? So now, so far in the course, we talk about elementary programming, we talk about if statements, we talk about loops. So these are somehow maybe hard for those of you who are first to Java. But now, we talk about another aspect of Java, which is called object orientation. So this is also hard, but in a different way. Okay? Conceptually, you have to be very clear on what's going on. So for today, I wouldn't be too ambitious. I want to do just a little bit of slides to give you some intuition quickly, 10 minutes. And then I'm going to prepare tutorial videos for you so you can follow them, get things done, hands-on, and also do some lab exercises to build your intuition. But for your lab test 3, which is going to happen 2 weeks after lab test 2, it's going to cover classes and objects, exactly this. So you want to make sure you pay attention to the next 2 lab exercises, especially the tutorial videos. But I'll prepare you for that. You don't have to worry. So let me just give you some very quick intuition, and then I'll pick up from there in the tutorial videos. Okay? Now, let's think about what we have done so far. Let's think about the code structure. So far, for every task of your lab exercise, you only have one single class to program. For example, determine Fibonacci sequence.java or generate Fibonacci sequence.java. And for every such class, you just have a single main method. Inside, you got scanner, you got other stuff, right? Just a single method and single class to worry about for each task. However, that's too constraining for Java. Java is way more expressive than that. Okay? So what we have done so far, just to keep things easy for you to learn the for loop and if statements. We only got the main method. However, in general, you can have more than one classes. The number of classes you may want to have is completely depending on what you need. For your lab test 3, I can tell you that you have to deal with 4 classes. One class with the main method and 3 other classes, somehow they are interconnected to each other. So interconnection is the difficult part I would like to get you prepared for. Okay? I want to give you a little bit psychological preparation for that, right? Before we get there. It's going to be tough, but you got several weeks to get it prepared. So in general, you can have more than one classes. If you actually work in the software industry, don't be too surprised. You may have more than 100 classes to deal with. It's absolutely normal. Okay, but for this course, only up to 3, okay, or 4. And also, each class does not just have a main method. The truth of the matter is, there's only a single main method of your application. Other than that, you might got other kinds of methods, which I will talk about in detail, okay, starting from next week. And then, what about object-oriented programming over here? Let me give you a little bit of intuition over here, okay? We wouldn't do any too much programming today, okay? Okay, we're going to use classes. Classes are basically like a class determining Fibonacci sequence, class, person, right? Okay, you're going to use classes to define templates. I will try to explain to you later what templates really mean a little bit later. And also, we're going to use objects. So you can see, we already see 2 terms over here. Classes versus objects. They mean something related, but completely different. They're related, okay? To make it very intuitive to you, you can think about classes is simply templates, something you can create something out of, okay? For example, if you have some template for your Word documents, you can create different instances of your document from the template, right? And also you got objects. We'll get programming example later. And now, what's going to be challenging later for your labs and also the lab test is you somehow have to manipulate the different classes you create and also manipulate different objects you instantiate on those classes. That's the difficult part, manipulation. Okay? So that's something we'll definitely focus on. Okay, so now what I would like to do, I want to show you some flowchart very quickly to give you the overall picture about what we're going to do for object-oriented programming. And by the way, whatever you learn about if statements and loops, they are not obsolete. You can still use them when you talk about object orientation, but everything will be based on that. Okay? So what I would like to do is I want to show you a diagram over here. Okay? That's going to flow. I'm going to enlarge that each component in a minute. Okay? I'm going to go over all the 3 steps over here. So these are the 3 things you will have to do later. Okay? So what I will do is, let me just go over some bullet point. That's the same diagram. I also make the large one in the course website, lectures page. You can also go over them. Okay? This tutorial video, which is what I recorded for 1022 last year. You can feel free to refer to it if you want. But I'm going to tell you the same stuff over here in the class. Okay, so now there will be 3 things we're going to talk about. One is called observe, and then model, and then execute. Okay, so these are the 3 things I'll talk about in the diagram quickly. Okay, so now let me just talk about the first one. The very reason we say Java is object-oriented. Okay. So for example, we say Java is object-oriented, but the C language is not object-oriented, simply because you can, okay, let's say object-oriented over here. Okay. In the real world, everything is an object. This table is an object. My Apple Pencil is an object. Myself is an object. Everything you can see by your eyes is an object. And by using Java, in theory, you can simply program everything. It's simply just possible. For example, let's say sometimes we also say objects are simply entities. Okay? So sometimes I might use the word entities as well. Okay? So now, let's talk about 2 kinds of entities, different kind. Okay? different kind of entities deserve different attention at the Java level. Okay? For example, let's say do just one example to begin with. Let's say we got the kind of entities for persons. For example, you can observe there's a person called Jim. There's also a person called Jonathan. You got many other persons. Okay? That's what you can observe in the real world. So now, how do we actually program the entities we observe in the real world into Java? So that's something you have to observe first of all, right? You observe their entities for persons, in which case, for example, Jim and Jonathan are simply just two examples. So now, how do we turn our observation into Java? Is something I call model. Okay? And you want to somehow create some model, programming models for your observation. Okay? The first stage, luckily, at the introductory level, you don't have to do too much in-depth observation yourself. I will normally tell you my observation result. You can take it from there. Okay? Now the second and third step are important. Okay? I'll show it to you. So now we talk about compile time. Remember? Right? We talk about the distinction between compile time and also runtime. So these are the two things you have to pay attention to, right? Given some observation, which I might give you most of it, you want to know how to create Java classes at the compile time and how to run them as objects at the runtime. Okay? Let's do that very quickly. Okay? So now, in the case of the person, because we know that we observe both Jim and Jonathan, they are simply just persons. So what we will do is, at the compile time, we're going to create a Java class. Okay? You start with a keyword class. We have done this actually up to now. You just didn't realize it's actually for that purpose. We create a template called person. So this is a template. Template in the sense that every person instance must exhibit whatever you define inside the person template. For example, for the person class, we declare 3 variables. We call them attributes in this case. Okay? Even though you can understand them as variables, but it now makes more sense to call them attributes. So each one of them is an attribute for the person. For example, for each person, Jim and Jonathan, both of them, they have a name. They have a weight, they have a height measure, right? If you want to calculate the BMI, which we did previously, you want to know the person's name, the person's height, the person's weight. And every time you declare attributes, you always have to say what the type is for the attributes. For example, name would be a string, the weight would be a double, and the height would be a double. You can see everything is kind of familiar to you, but we organize it in a way that will give you some new insight into the what you learned before. Okay, let's say as easy as that. Let's say at the compile time, we simply declare a class called person. Okay, that's valid syntax. So now, that's about the compile time. How do we actually somehow manipulate the person in a way that simply simulates what's going to happen in the real world? Okay? What we're going to do is we're going to have execute over here. Okay? So which means I can simply try to do some tester. I'll talk about tester next time. But given this is a template, this is what's going to happen at the runtime. Okay? So now we talk about runtime over here. Runtime, which you can see from the debugger. And I'll show you that in the tutorial video. At the runtime, you're going to have different instances or different objects. So these are the instances and also objects for the same class. Okay, over here I simply say it's a person class instance. It's a person class instance. One is called Jim. The other one is called Jonathan, right? You can see both instances, they have name, they have weights, they have heights. So the attributes are the same, are common to all the instances. So also for the person called Jonathan, he also got name, weights, and heights. So that's why it's called template, right? From the previous illustration over here. But now, what's important over here is like this. It's like between you and me. All of us, we have a name, we have a weight measure, we have a height measure. However, what distinguishes between each one of us is the exact value for each measure, right? So for example, you can see for person Jim, his name is, value is Jim, the string value, but for Jonathan, his name is simply Jonathan. It's different, right? And also for the weight measure is 80 versus, so they can happen to be the same. And also for the height is 1.80 versus 1.80. It can also be something like maybe 1.92. That's something we can change. Okay, so that's basically intuition I want to give you just to begin with. And then the next time you're going to see this will be in the tutorial videos, and also starting from Monday, we'll do a little bit more programming to give you more intuition. Okay, so I'll see you next week.